Hello everyone, this is Martha from the Academic Support Center, and this is a pre-calculus video about verifying trigonomic identities. This can be tricky for students. There are a lot of different ways to do it and a lot of steps, so we're going to start off talking about some helpful strategies. So helpful strategies are to pick one side, and oftentimes you'll get, you have the equals bar in between. Pick one side and keep that the same and try to get the other side to match it. And oftentimes it's easier to start with something that's more complex and to simplify it. So if there's one side that looks a lot more complicated, try that side first. The next tip is to apply functions, either multiplication or addition, multiplication, division, subtraction, and sometimes combining or breaking apart fractions. So if I have star plus triangle over smiley face, I can break that apart over this operation, and this is equivalent to star over smiley face plus triangle over smiley face. I've kept that base. Another example of applying functions is if I have a over c plus b over a, right? I can combine this into one fraction by multiplying each fraction by 1 that just looks a little different to get a common denominator. So this would be a over a times a over c plus c over c times b over a. And if I combine these fractions together, I would get a squared plus bc all over ac. And we can use this, whether it's breaking apart or combining fractions, a lot as we do trig identities. The next step is to reduce things down to sine and cosine. So if I've got tangent, sometimes it's helpful to write it as sine over cosine. Sometimes it's just easier to see patterns that way, and that's why we can do it. This doesn't always help, but it can be something to try. The last helpful strategy is just keep trying. If you hit a wall, take a few steps back and try something else, and continue to practice. Okay, so for this video, we're going to take and give an example. We're going to use the same example, but we're going to work it two different ways to show that there are more than one way to verify an identity. So we have the sine x times tan x plus cosine x equals secant x, and we need to verify it. And oftentimes as I work through these proofs, sometimes I drop that x and just write sine times tan plus cos equals secant. And so that's what I'll be doing just for time's sake, but it is proper to keep that x, or to keep that if it's 2x or whatever it is, through. So let's get started. So I'm going to keep this side the same, that's secant x. I want to keep it and try and simplify this other side. So first I'm going to rewrite with sine and cosine. So I've got sine over 1 times tangent is sine over cosine, right? And then I've got plus cosine. And I'm going to say, okay, I can combine this fraction into sine squared over cosine plus cosine. Now, I'm going to try and combine fractions again, but what I'm going to do is I'm going to multiply by 1, because I want to get them into the same fraction. So I'm going to multiply this cosine by cosine over cosine. And what I'm left with is sine squared over cosine plus cosine squared over cosine. So I've given it a common denominator for my fractions, and then I can combine them where I've got sine squared plus cosine squared all over cosine squared, or all over cosine. Ooh, don't want to throw an extra one in there. Now what I can then do is I can use my Pythagorean identity of sine squared plus cosine squared equals 1. Because it equals 1, I can put 1 in for my sine squared and my cosine squared. So this gives me 1 over cosine. Now this is the reciprocal identity. I can use the reciprocal identity that secant is the same as 1 over cosine. So I can say that 1 over cosine is secant, and then I've taken my left-hand side and made it match my right-hand side. And so with this, I took the more complicated side, said, okay, I'm going to try and simplify that, wrote everything in terms of sine and cosines, worked to get a common denominator. I then used my trig identity for Pythagorean theorem right here to say, okay, that is the same as 1. And then that allowed me to see that, okay, this is the reciprocal identity for secant. Now we're going to try keeping the right or the left-hand side the same and changing the right-hand side. All right, so we've got the same thing to verify here where we've got sine x times tan x plus cosine x equals secant x. But this time we're going to rework the problem from a different angle. This time we're going to choose to work with secant and keep this side, the left side, the same. And so this is what we're going to do. We're going to first write, we want to try and get secant to look like that side. So let's give it a try and see what we can do. So we're going to write secant x as 1 over cosine x using the reciprocal identity. And then what we can do is we can again use our Pythagorean theorem here. For 1, we know that that's sine squared plus cosine squared. So we're going to rewrite that. We've got sine squared plus cosine squared all over cosine. And then what we're going to do is we're going to split the fraction. Well, it's not really splitting the fraction, it's just changing the way that it looks. So we're going to have sine squared over cosine plus cosine squared over cosine. We're going to do a little bit of simplifying here and changing. So first we've got cosine on the denominator. We can cancel one of these out. And so we're left with sine squared over cosine plus cosine. Now let's see what we can do with this. Sine squared, we can write it as sine times sine over cosine plus cosine. I wonder if we can break this apart. If we can rewrite this as sine over 1 times sine over cosine plus cosine. Hey, look at that. We've got tangent right here. So we can rewrite our identity as sine times tangent plus cosine. And we have now proven that the sides match. And this is just to show that there's more than one way to work an identity. As long as you're following all the rules and keeping all of the identities accurate, then you're good to go. Get practicing and have some fun.